All right, so we're going to talk a little bit about differentiability. Obviously, the conditions you're checking for is that the function is continuous, and secondly, the one-side limits from both sides are equal at that particular point. If we look at this example here, right, this is a graph of y equals absolute value of x. I'm actually going to take that circle away and make it a little bit bigger. And, kind of shaky lines. But if you look at the slope of this line, this is why it's really easy to use as an example, is that the slope on the left side of that line is a -1. The slope on the right side of the line is +1, which means that the two one-side limits exist, but the two-side limit does not exist for the slope. And so when we look at probably like the next example, we would use something like the jump and the hole. This would be the discontinuity case, right? And in the discontinuities, we're looking for a place where it doesn't even satisfy this first condition, right? It's not continuous at this point. And so that's what we see here, right? There's a jump, right, that occurs. And what we see here, right, that you can't actually cross over the hole without lifting your pen up, drawing a circle, and then crossing over. And that violates the first part of the definition, so that's not continuous. That's not differentiable either. The cusp and the corner are pretty closely related. Both of these are continuous, right? Obviously, they both hit the origin, and they both have the distinction of having slopes that are unequal. The difference is that in the cusp case, on the right side here, we have the slope on the left approaches -infinity, and the slope on the right approaches +infinity. Right, so these are supposed to be very, very vertical. And it's very common to see when you have something in this form, right? If you have something that's an odd number on the bottom and an even number on top, right? Because you could still have negative values would be negative, but then you would square them. If you have a negative if you have an odd number on the bottom and an odd number on the top, we generally get the vertical tangent case, in which case you have this situation where the slope as we approach x equals infinity is infinite from this side and infinite from this side as well. So, and even though the two one-side limits both approach +infinity, we don't consider them equal. We say that they approach infinity, they're not equal to infinity, and that's why it's not differentiable.